Alright, so in this video, we'll be looking at the Java implementation for the October-November 2025 9618 variant 41 question 1. So let's go ahead and look at the question right here. For this particular paper, there was a text file that we'll be using for question 3. That's the source file that we'll be using for question 3. But for questions 1 and 2, we don't have any source files that we'll be working with. So question 1 here says that a program stores integers in a stack. The stack is represented as a 1D array of 30 elements with the identifier stack. The global pointer top of stack stores the index of the last element inserted into the stack. Top of stack is initialized to -1. So we are to write a program for part A. We are to write a program that's going to, we are going to write program code to declare top of stack as well as the stack array, as it were. So let's actually go ahead and look at the implementation that I have going on here. So you see that I have my implementation on lines 9 and 10. That is for the stack and the top of stack arrays and variables, as it were. So you realize that I'm using the repa class for integer, which is integer, instead of the primitive int type on line number 9 there. The reason why that I'm doing this is because if you read the question, you realize that we are supposed to initialize each element in the array with a now value, right? So we are not supposed to initialize with 0, but we are supposed to initialize with now. So if you were to go ahead and declare the stack variable as the stack array as an array of integers, that is the primitive integer type, you'd realize that you run into a compilation error because you cannot assign now to an integer, right? So that's why we're using the repa class here. So our repa class, we are using integer, and it's an array that's going to hold 30 integers. Then on line number 10, we are declaring the top of class variable and initializing it to -1 as dictated by the question over there. So of course, we'll go ahead and copy this code and paste it inside of the evidence document. Moving on to the next part of the question here, we have a function called push that's going to take an integer parameter. Then if the stack is full, the function is going to return a false. Otherwise, if the stack is not full, the parameter is inserted into the stack and the pointer is updated and the function returns true. So essentially our function, from reading this, we know that it's going to return a boolean true or false. So let's go ahead and look at the function declaration right here on lines 13 to 20. So we have the function header going on line 13, and the return type is boolean, as we did see from the question there, and the name is push, and it's going to take an integer which we are going to call value inside of this function. Then if the the top of the stack, right, is essentially going to be called to -1, like what they said here. So if the stack is full, the function returns false, right? That's what we are implementing on line number 14 there. So we're checking to see that if the top of the stack is equal to the length of the stack -1, then we are going to return a value of false, meaning to say that we cannot push anything onto the stack. Then on lines 17, 18, and 19, we are handling the alternative, in which case the stack is not full, so we have to insert the parameter into the stack as well as update the pointer. So that's where you see we have top of stack being incremented by 1 on line number 17 there. Then you see that we are taking the value that we supplied to the push function, and we are storing it at that particular index position inside of stack. Then of course we are going to return true to show that we're able to insert that value onto the stack. So of course you then go ahead and copy the code and paste it inside of the evidence document. Moving on to part C, we have a function called pop that's going to return the next integer in the stack and update the pointer as appropriate. If there's no data in the stack, the function returns the value -999. Write program code for pop. Alright, so switching to the solution here that I have going on lines 23 up to line 31, that's where we have our function declaration for the pop function. And it doesn't take any parameters according to the question here, or according to the requirements. It doesn't take any arguments, so we don't have a parameter definition there. So in essence, it's just it's going to return an integer, as it were. So If the top of the stake is equal to -1, it means that the stake is empty, so we have to return the flag variable that we were told here, which is minus 999. Otherwise, we proceed to take the value that is at the top of the stake and store it inside of this value variable that we are declaring on line 27 there. Take note that this value variable right here is not related to this value variable here. Think back to when we talked about variable scope in the Java series. So they are not related whatsoever. So it's safe to use value variable right here on line number 27 there. So we are now holding the value that was, rather the number that was on top of the stake inside of that value variable. Then on line 28, we are now setting now as the new value, because remember we've removed the value that was currently at the top of the stake. So we need to assign a value of now to show that it is there's nothing going on there on that particular position as it is. So on line number 29, of course, we are updating the value for top of stake. In essence, we are decrementing it by -1 so that the pointer has to move backwards as it were, because since we are removing the value that was at the position that we set to now on line 28. Then on line 30, we are simply returning the value to the caller of the pop function. So of course, you can go ahead and copy the code and paste it inside of the evidence document. Moving on to part D, it says here that the main program generates 40 random integers between 0 and 1000 inclusive, and attempts to insert each one into the stake using the appropriate function. If the return value from the function call indicates the stake is full, no more integers are generated and stake full is output. Write program code for the main program. So we are supposed to implement a program that's going to generate 40 random integers, then try to push those values onto the stake using the push function as it were. So let's go ahead and look at that implementation going on here. That's for D. So I have it down here inside of the main method. So here we are going to generate 40 random integers, then attempt to push them onto the stake. So the first thing that we need to do is we need to initialize our stake. So this is what we are doing on line 64 and 66. We are using a count controlled loop or a for loop as it were to assign the value of now to every element inside of the stake array as it were. So remember earlier on we said that stake is of type integer, that is the wrapper class, not the int, the primitive. Because if you set it to int, the primitive, you're not going to be able to do this. So you need to take care of that. Then on line 68, we are creating a random object called rand, which is essentially going to allow us to generate random numbers as it is. Then on line 40, since we want our loop to run 40 times, we are going to set that right there on line 70. So our loop is going to run 40 times. We are starting to count at index position 0 up until index position the 39 as it were. But remember that from 0 to 39, we actually have 40 elements as it were. Then on line 71, we are now using the random object to generate a random integer between 0 and 1000 inclusive. So you need to remember that the way a next int works is that it's going to go up to, but not including, the number that you have given as the argument. So let's say you wanted to output, or you wanted to generate random numbers between 0 and 10, right? The parameter that you'd actually pass in right here would be 11, is it? So here, since we want to go up all the way up to 1000, we actually have to take into account that is not going to include the last element. So here, that's why we set it to 1001, right? So it's essentially just going to go from 0 to 1000. That's how the int, the next int function inside of the random class works in Java. Then we go on to check to see if the number is not pushed on line 73. So we are essentially just sysouting a message which says stake is full. Let me check if I did import static there, so I can get rid of that system so that we keep things a bit short as it were. So out.println stake is full, then we break out with the loop as it were. So this is going to happen 40 times rather, until the stake is full, at which point it's simply going to break out of the loop and stop trying to push elements onto the stake as it were. So of course, you then go ahead and copy this code and paste it inside of the evidence document. Then moving on to part E, we have a procedure called find values, and this one is going to pop each integer from the stack until the stack is empty. It's also going to find and output the largest number that was in the stack in an appropriate message, and it's also going to find and output the smallest number that was in the stack with an appropriate message as well. So we need to write program code for find values. So let's look at the implementation that I have going on lines 34 up to 57 there. All right, so on line 34, we have the function header. Our function is called find values. Again, it's a static function because we are not creating any object from this class. So if you are not going to be creating any object from a class, just know that your functions are going to be static. Again, you can always refer to the Java series where we go about all those syntax and Java conventions in much more detail. Then on line 35, we are checking to see if the top of the stack is currently equal to -1. So remember, -1, if the top of stack has a value of -1, it means that the stack is empty. So we are going to output an appropriate message on line 36, and then we simply return or we simply break out of that particular, or rather we return control to the caller of the find values method. Then on line 40, we want to set the largest, we want to declare values that are going to hold the largest as well as the smallest integer that is inside of the stack array, as it were. So what we need to do is we need to initialize the largest and smallest variables with ridiculously high and low values, as it were, so that we can then use those to compare if they are greater or they are smaller than the values that we have going on in our stack, as it were. So on line 44, we are using top of stack. We are checking rather to see if top of stack is not equal to -1. So if it is not equal to -1, then it means we definitely have something inside of our stack array. So we are going to pop a particular value and hold it inside of the value variable that we have going on line 45 there. Then on line 47, we are checking to see if value is greater than largest, at which point value is going to hold or is going to replace the largest variable, as it were. Then we are going to check if a value is smaller than smallest, as it were. Then we take that value and assign that as the smallest variable, as it were. Then of course, after that, we simply output the largest value and the smallest value on lines 55 and lines 56. Then of course you go ahead and copy the code and paste it inside of the evidence document. Then moving on to the next aspect, here we have F item 1, and we are to extend the main program to call find values. So let's come back to the main program right here. You see that on line 70, line 80, that's where we are calling the find values function. And of course, you would go ahead and copy that code and paste it inside of the evidence document. Then the last aspect requires us to test our program and take a screenshot of the output, as it were. So let me pull up the console, clear it out, and run the command here. So you see that eventually, after pushing some values onto the stack, it outputs the message stack is full. Then it goes on to give us the largest value that we have in the stack. It's also going to output for us the smallest value that we have going on to the stack. Then maybe if you can run it one more time, you see this time around we get different values simply because remember, these numbers that are being pushed onto the stack, they are random numbers. So it's simply going to generate that random number between 1 and 1000, then push those values onto the stack, and you see that the largest value in the first instance that it generated was 928. Then in the second instance it's actually 995. Then the smallest there then was 22, and the smallest now is 1. So of course you could go ahead and take a screenshot of your output and paste it inside of the evidence document, as it were. So that's just about it for this one. I will see you guys in the next one.